Alright, I'm Eduardo Garcia, and this is video project 2 for ME210, and we will be focusing on the water sprinkler out in the lawn for daily use. So the sole purpose of this project or video is just for me to personally know how strong the water comes out of the hose and how much of it is useful for it to cover the whole lawn. Just because sometimes I have to go back and forth between the lawn and the knob of the hose to see if it's coming out perfectly, if it's not shooting too far out or not coming out at all. So the sole purpose of this is how fast does the water come out of the sprinkler for the perfect distance of the yard. Alright, so here we have a video of the sprinkler itself at work. You can kind of see I'm kind of like loosening and tightening the grip on the hose just for the water to come in and out, just so you can see it better. It's very faint, but you can barely see right now that it's at a perfect distance where it's covering the whole right side of the lawn. The left side of the lawn, sorry. And usually whenever I put it too strong, it'll go out to the sidewalk or go across the side, the walkway. So that's what I'm mainly trying to figure out. So here there's a video or a picture more of like the distances and measurements of everything. Here we have that I kind of estimated it using a protractor. It's kind of hard, but I estimated about a 50 degree angle from the floor to where the water is shooting out perfectly to the very edge of the yard. The yard itself is 14 feet both ways, so it'll be oscillating back and forth, so 14 feet both ways of the yard, and it's slightly elevated from the floor by 0.25 feet, which is just 3 inches. And it's mostly about all the calculations and numbers we need for these kind of so here we have like the kinematic equations that I've used and the given data. So like I said before, we have the theoretical 50 degrees of oscillation between the floor and the perfect distance. It's about 14 feet from the sprinkler itself to the very edge of the yard. I kind of did this a little bit like tediously using a timer. I kind of like just looked at slow motion when I was recording the water. Kind of got about 1.1 seconds from when the water comes out of the sprinkler to the very edge of the yard. So kind of tedious, but my math kind of works out on it. And obviously we have why not of how high the water starts from the floor is 0.25 feet. And the two kinematic equations that I use to kind of like figure out what V naught was, which is the perfect velocity of the water coming out of the sprinkler, are these two equations, and I use those to kind of solve. Here we see I started off with the horizontal distances just because I wanted to know how fast the water was coming out. And since I already have time, which was 1.1, the only unknown variable was V naught here, shown in the x of t is equal to V naught cosine theta t. After I plugged in all the known variables and data we had, V naught came out to about 19.80 feet per second, meaning it was coming out of the hose and the sprinkler at 19.80 feet per second. And then I checked if everything was kind of like working out, the math checked out. I used the horizontal kind of kinematic equation also, and it kind of cleared out too, because if we know that it's going up and it's coming back down to zero, if we plug everything back in, including the seconds and the velocity, it should be zero, which here clearly cancels everything out and it is zero. So I'm assuming we're kind of very precise on the distance and the velocity used. And again, I used some kind of like, I searched it up kind of in a way to see how much distance is covered within each angle, and it's showing here that at 50 degrees 14.1 feet is covered using that velocity. So it kind of clears out and checks in that when it's using that certain velocity and at a certain angle, it would cover the 14.41 or 14.1 feet. So to end the video, I kind of solved that I have to have my hose shooting water out at a certain angle of 50 degrees at 19.80 feet per second for me to cover all 14 feet of each side of my lawn, which should help for future uses, as it's a hassle just going back and forth trying to figure out how fast it is. So now we know.